Hello everyone, my name is Federica Gazzelloni and this is the third part of the Oregon Spotted Frog series. So in this video we are going to build this network visualization, and before going to making this plot, I'd like to show you how the project folder is made, and how you can assemble your scripts all in a separate folder and then access them automatically. And this is something that we see in the following parts of this series. Okay, let's share some more interesting things. Okay, here, I don't know if you can see it. Okay, here you can see this is my GitHub repository for Study Tuesdays, and this is inside the folder data 22, and this is week 31 frogs. Okay, so I've made this repository from RStudio. Okay, so you have a container folder and then the two files that are, so the R markdown is for assembling all the other plots, while this PNG is the final visualization that we have seen. So if I now go to R and to show you what's happening when I have this container. Okay, so inside you can see this is my week 31 frogs. So there is a container folder exactly the same as shown in the GitHub repo. Okay, so in the container folder there are more folders like images, models, and scripts. Inside the scripts you find all the script for making the single plots for the main visualization. So we have seen the rock plot, the VIP plot, and now today we are going to build this network plot. So the file is here. Then in the other folders like images, you will find all the images, and then there are models folder with some modeling inside. So the many models is the one that we have seen in the first video. So now today we are going to build up this this network, and which is this one here. I have seen. Okay, so in this visualization you can see there is so we have our frogs data, and we have mapped this network in a way that all the frogs that are located in pond, reservoir, and river then are mostly captured within deep water, shallow water, and no water. So mostly captured in shallow water, as you can see, some in deep water, other in no water. So how we can do this plot? Let's go back to R. Okay. I don't see the sharing. Okay, so I'm not sure if I'm sharing this this thing. I'm going to share that again. Okay. So I'm sharing this. Okay, now I see it. So I'm sharing this this script to make the network plot. So the library that we need are the tidyverse, the igraph, and the ggraph. So make sure you load them, you install it, then you load them. Okay. Then we need our dataset, which is from the Tidy Tuesday GitHub repo. So we have our frog dataset, and we know few things about it. We have already seen it in the other videos, but now we have a quick look again. So this is the dataset. So you have the site, which is Crane Reservoir, subsite, the habitat, the survey date, etc., etc. So our final visualization is to make a network that goes from the substrate, from the habitat to the water, passing to the substrate and considering frequencies. Okay, so these are the vectors that we need for making this visualization. So we have, we can even do this like select, and we copy this vectors here. So we have okay, because I do need this janitor clean names first. Okay. So now we can see, so this is the data set. So from the entire data set, we select just the vectors that we want to use in our network. Okay, obviously, if we do a bit of reasoning and having done models and having done variable importance, both in the model and then, as in the previous video, having chosen some important predictors, made a visualization dividing from the gender of the frogs. So we have like an idea of what are the variable we are interested in. So we can see that the habitat is very important driver. Okay. And we are interested in see, okay, we know that the habitat is composed of three classes: pond, river, and reservoir. Now, we want to know how these frogs are captured and whereabout within these three class of habitat. So are they most found within pond in deep water or in shallow water? And so through this network visualization, we can see that we can see that most of them are found in some water location more than others. So starting from our dataset, we do the same thing as before. So like clean names, setting the date as a date, then the female as a factor. In this case, is not needed because we are not like making this reasoning for doing this visualization, so we don't need that. But we leave it like that because it's part of the main visualization. So we then arrange a few things and set up the names to have it clear. So to make the network plot, okay, so we are interested just in captured frogs. So we filter the detection on captured, and then we select just these vectors. Then we use igraph, and from this is a data frame. Okay, so this is our data frame, and there is a nice function from igraph, which is graph from data frame. We can even have a look what this function does. And this function creates igraphs, graphs from data frames. Okay, so this is what we actually need. So we have a data frame, and we like build a graph. So this function basically transforms the data, takes a data frame or an igraph object, and then because it does both ways, and then basically what it does is basically transform the data in a way that can be used in a graph format that can be used. So you can even see it. And this is what it does. Basically, it's now a graph. There are a specification of how many elements are in the graph. And then you can see there are attributes, which are name, substrate, frequency, which are attributes that are used in the igraph. And then there are some ages. So as you can see here, it's like pretty clear. So you see that pond goes in deep water, and there are a certain number of those ones. And then pond goes in shallow water, and there are some of them as well. So the most of job is done by this function. Then you can use this ggraph function from the ggraph package with different layout. But now, for now, we use the auto. You can even see what this function does. And this function creates a ggraph plot. So it's the equivalent of the same, the ggplot function. So just that it deals with graphs. So it takes care of setting up the plot object along with creating the layout for the plot based on the graph and the specification passed in. So there are several layouts that can be used. So in this visualization, we have used the auto layout, but there are other different type of layouts. So you can see you can even pass a string, a function, and matrix or data frame. So you can see, for example, that when it's talking about the layout, so it's up to the user to understand the data and choose an appropriate layout, for example. Okay, So for standard node edge diagrams, igraph defines a long range of different layout functions that are all available through the igraph layout. But so in general, so igraph layout where specify layout is specified using all the algorithm arguments. So you can even basically use the algorithm argument to make more type of layout. But as I said very clearly, that you need to have an idea of what is your data you're dealing with, what are the data you're dealing with, because otherwise the layout might not be what expected. Okay, so for example, the auto layout, the default layout, is the one that we use. Okay, then there's igraph, dendrogram, linear, and other like tree map, partition, hive, so different layouts. So here we use the auto. Okay, so now I cannot see it. So it says using this Sugiyama as default layout. Okay, but it doesn't mention this in the documentation. But how can I say? It's originally Sugiyama, then defined as auto. Okay, so we cannot see things in here, so we see nothing at all, because as it's like we use the ggplot function and without any geoms. So we need to add some geoms to see something in the canvas. So for now, we have a canvas, empty canvas, set the layout. So now we start adding things, okay? So we can, for example, use the geom edge, okay? And when we do, like, if we do ggraph, for example, and then double colons, double dots. So there is a list here that you can have a look and see, because it selects just those geoms from the gggraph package. Okay, so you have different type of edges that you can use. You have the arch, you have the band, you have the diagonal, the elbow, the fan. So I've tried few of them, just like to see how they were. Then decided for this one here, which turns out to be quite nice, the Age Fun 2. Okay, if we have a look at this function here, so the geom age fun draws ages as curves of different curvature. Okay, so draws curves basically. So, and this is what I wanted. So there is the fun and the fun 2, and there's like a little difference between the two. So now we can even see the difference of the two, but in this case, actually it cannot very well. So it doesn't change much basically if you do the fun or the fun 2. So inside the geom, we specify that we want the color. So have a look at this geom. Okay, so if I do, for example, the fun instead of the fun 2, okay, so as you can see, there is not much difference. Okay, and for the type of data that we are providing. Okay, so inside this geomage, we have specified a color, which is the stat index. So we are doing like the counts of the elements, but this is nothing from our data set. So it's something that you can use because in the graph, okay, you have an index, and he does the counts of the elements that repeat. So you can assign the color to this statistic. In this case, I add this reverse function because I want that the highest value be more like low, and then the lowest value be higher than the other one. So I put this reverse function. Then you can establish the transparency, the strength, and the line end. Okay, so this line end here. So you can like play with it and add and change some with some different options. Okay, now we are not satisfied with this visualization. What do we miss? We miss the labels. So we want like understand and see very clearly what is going from here to here, what is the group of belonging. Okay, this substrate and frequency are the ages. Okay, so when you say name, means take the vertex. Okay, so we can then see that. Let's see what's happened, what changes. Okay, so now we've got the names, the on the top and the bottom. So both of these two datasets are named. And then now the remaining very little part of the visualization is like customization, like adding features, things, like specify the color, so changing the names. So you can find everything from ggraph. For example, there is even a scale edge color viridis function, or the scale edge alpha continuous. So for example, if I do this too, you can see that we have a scale color viridis with an alpha continuous. So it's a little like a bit of there is a little bit of transparency as well, because the alpha can be like specified here and should be inside the aesthetic. if we in this case we haven't done it. So if I do that, it should be the same. Okay. So okay. So I think this is not needed, because then I move that somewhere else, because wasn't needed. Okay, let's go forward, and then the ggraph, we can even add this alpha continuous, putting in inside here and asking for the same things. But then I had two legends, and I even merged them to have one legend, but then I didn't need it. So I think that this is this can be just comment out. So then in the ggraph function, you can find even a team graph. So and see that where is it? Let's see what changes. Okay, so now this is the visualization, and what else? There's still a few things. Now what is it doing? Okay. So now we add the title, the subtitle, caption, and set some other customization in the theme, within the theme function, using the theme function, for example, the type of character and the legend position. Okay, so if we run this bit, okay, this is our final plot. Okay, so cannot see very well, but then in the next video, when we assemble all the plots with cow plot, we see how can be like resized within well, after it's saved as a PNG. So this is the final visualization, and it's everything. Okay, bye now.